time is now. Brian, the floor is yours.
Perfect. Thank you, Kevin. What a great segue. And I hope we have the same energy that TJ had during his tire presentation. But it's my pleasure to actually be with Bob Albano and also Scott Ames too. So we got two guys here that are really, really good in the suspension area. Bob, you've been with Hendrickson for about 15 years, mainly focusing on the fire apparatus side. Scott, with that, you've been in a Rayco grinding area for probably 5-6 years.
Correct.
I'm guessing.
Yep.
And really, really big in the fire apparatus side too. So, gentlemen, I'm going to give the floor to you. Bob, I'm going to start with Bob, and you're going to take it away.
All right. Thank you, Brian, for allowing me to join and talk a little bit about the technologies that Hendrickson is leveraging in the marketplace when we're looking at designing suspensions as a whole, not necessarily just for the fire and rescue market, but what are we doing across all the industries to make sure that the products that we're putting out in the marketplace are going to A, survive, and B, provide the best performance that we can. So with that, I will go ahead and get started here. So one of the things that we've invested in heavily over the last couple of years in terms of technologies is our ability to model and be predictable in terms of.
Sorry, Bob, super quick. Are you planning on sharing a screen right now? Because we're not seeing that.
Yeah, let me escape out of this. And I think I got a, Brian, are you, sorry.
If you need me to share.
Yeah.
1 second.
Not giving me an option to share.
Is it giving you the option? Brian, is this the slide that you sent me? Session? No.
No.
Sorry, 1 second.
No, Bob has it on his side, Kevin.
I got it.
There you go.
Fantastic. Yep, we can see that now.
All right, back up here a second. Apologize.
All right, no worries.
All right, so like I said, one of the things that we've invested heavily in is our ability to be predictable in terms of when we're designing a suspension, that what we're seeing on the modeling is what we would see in real life. So one of the things that this provides us the ability to do is predict the ride and handling and steering virtually without us having to essentially destroy a truck when we're trying to take a look at, okay, what are sort of the roll stability of this truck before it tips over. Another thing this allows us to do is reduce the development time and then obviously reduce the development costs to allow us to get products to the market faster. Another thing that we're invested heavily in is providing structural analysis and not only looking at suspension as a whole, but what are the impacts that has onto the chassis, i.e. I know what the load forces look like from a suspension standpoint, but what am I doing long-term to that chassis? It allows us to model for stresses and deformations in the metals. Another big thing we look at is fatigue predictions, and we can tell essentially by modeling. When you look at sort of the image on the left, anything in red is what we call typically a hot spot. And what we do is we will put that through its modeling and we will start to test that. And if you look at sort of our test, our fatigue prediction was this part would last 1,481 cycles. And when we tested it, it actually lasted 1,000 or 10,150. So we're within typically 1 or 2%, and we can predict where it's going to fail. So if you were to look at this part here on the left, it failed essentially right at where we predicted the hot spots were as stress risers in that metal. Sorry. Another thing that we look at is really vehicle dynamics, and we want to understand how that suspension is going to perform. And we can replicate that on our test rig. So we'll look at roll stiffness. We'll look at the vertical rate of how much flex are we getting into that suspension. We look at bump steer. So when you're going over a railroad track, what is the degree changes of that suspension? Because that's what the occupant is going to feel in that steering wheel. We look at roll steer, and that's the relation from the front axle to the back axle. When you turn the front axle, obviously the back axle moves as well. So that's called roll steer. So we want to understand how stable does the truck stay while you're going through high-speed turns. And then we want to see what the lateral stiffness of that suspension is and what the comfort level is for the occupants. So obviously we spend a lot of time on testing. So you can see these are a lot of our shaker rigs that allow us to test torque rods. It allows us to test axles. It allows us to test trailing arms. So a lot of technology involved in getting suspensions to the market and making sure that we're predictable in terms of that product performance. This is what's called our Hendrickson tandem test rig. It's one of 2 in the world. And what this allows us to do is we go to essentially a bump course or say the Navistar Proving Grounds, and we will collect data. We'll bring it back and load this into this simulator. And this allows us to take what would typically take us 6 months in the field to replicate. We can do that in 6 weeks on this rig. So it allows a lot of flexibility from our standpoint to bring predictable products to the market, which is what we're all about. So that's sort of what we're doing on a modeling and testing standpoint. Brian, was there any questions on that portion before we sort of move on to what are we doing from a spring technology standpoint?
So one of the ones, Bob, was that, and I think you answered, does new suspension absorb the lateral movement that does not affect the cab and body? And I think you covered that part.
Yep. Yeah. Obviously, there's an interaction between the two, and we want to understand and the occupants.
Okay.
So one of the big things over the last, say, 10, 15 years is a move from multi-leaf springs to parabolic springs. And there's a reason for that. Typically, multi-leaf springs was a technology that was utilized back in the day. And the reason that it was used is they were relatively cheap to produce and they were predictable. They were pretty easy to service, but there is some downsides to that. And as we've seen sort of where the market has moved or where the environment has moved, as the corrosive materials that they're putting down on the roads really impact those multi-leaf springs, and that we don't have the ability as spring manufacturers to treat multi-leaf springs with any sort of rust inhibitor, in that I can treat it, but the second I stack those springs up and they rub together, it rubs all that rust inhibitor off. And as that rust forms on these springs over time, the springs become embrittled, they get hardened, and the spring rate goes up. And when a spring rate goes up, what the spring rate is that's the amount of force it takes to move that spring. So when we move to parabolic designs, one of the reasons we do that is there's gaps in between the springs. That allows me to treat the spring. It also, with the anti-corrosion material, so I've got the ability to now not have that those compounds rub off. It also allows me to move the spring more in that I'm not rubbing the spring together. Those gaps allow me to essentially lower the spring rate, require less force, soften the ride. So as the market has moved towards parabolic springs, the next thing coming down the pipe that we've invested heavily in are composite springs. I can now, with the composite spring, essentially give a product that will never change over time. It stays consistent from the day I build it till the day it comes out of service. Some of the benefits are from a composite standpoint versus a steel spring are going to be a weight savings. Typically, it's about 70% of weight savings for a composite spring versus a steel spring. It's corrosion resistant. One of the big things we fight in the fire industry is corrosion. I can develop a spring here that will never rust. It reduced noise. There's no spring snap. So typically when you go over a big bump, you'll hear those springs sort of hit. There's no noise to that. So you're not having to deal with that inside the cab. It's got improved vibration damping. That's all what we're trying to do is protect the cab and the occupants from the vibrations that are coming in from the road. They don't sag over, no matter what kind of spring it is over time, that spring will take a set as the metal changes over time, just because of the weight that it's being asked to carry. composite springs never change. I can stick a composite spring that's been on a vehicle for 15 years back into the original mold, and it'll fit exactly like it did day one. And then the springs typically last the life of a vehicle. You're not going to have to replace a spring.
So Bob, before you go on to that, it's hard to believe that they don't sag and they're going to last the life of the vehicle, because typically what we do in the fire service, we put all the heavy stuff on the right side of the vehicle and the lighter stuff on the left, and normally 99% of the time you'll see them sagging to the right. So are you saying with the composite spring that it won't do that?
So the way that the reason that's happening is typically each spring has a spring rate, right? And so the amount of force it takes, well, if you load heavier to one side, that spring's going to deflect more, because obviously the more weight you put on it, the more deflection you're going to have on that spring.
Right.
Typically, the only way you can fix that is to shim the spring. So you're essentially rising the spring rate, taking the spring rate up to offset. So you're essentially making one side of the truck stiffer so it's not sagging. In terms of this, what we would typically do is if you're going to load heavily, I would have the ability to customize one spring rate versus the other to equate for that weight variance. That's typically where air ride has a benefit over spring ride suspensions, because the height control valves sense weight and they add pressure to the system based on the weight that it's being asked to carry.
Very good.
So that's why we typically like to see air rides on fire apparatus, because we all know that they're not loaded evenly. So it provides me the ability to not have to stiffen up one side of the suspension to equate for that uneven load carrying.
Okay.
So obviously another thing that we're heavily invested in is trying to take maintenance items out of these suspensions. So typically a shock, for example, when we design a shock, the valve codes or the damping characteristics of that shock is typically at one weight rating. So when I develop a shock for a 24,000 pound capacity, what we do is we typically load that suspension in 24,000 pounds, and we'll develop a spring damping curve that essentially says I'm going to control the rebound and the up and down movement of the shock based on that weight rating. One of the things we're able to do with the zero maintenance damping is I can have essentially an infinite spring rate, in that we're utilizing the baffles and the air spring to act as a shock. So I can essentially have an infinite number of shock tunes. We've got about 500,000 of these in the field, and we've gotten excellent feedback on the trailer side. Now we're in the process of bringing this technology to the truck side of the market. So this is where we'll typically tend to bring this in. Some of the benefits of it, it has superior ride quality. As I mentioned, it's got uniform damping over the life of the air spring. There is no shock, there's no wear item. Typically a shock is a wear item. It's got a life cycle depending on how many cycles, how much you're running that truck, and then you're going to have to replace that shock over time. This air spring will never wear out. It'll never change the forces. Essentially stiffens up the suspension. They're also tuned for loaded and unloaded conditions, where typically a shock is going to be designed specifically for that loaded condition. So you will see some changes in ride quality based on the lighter weight ratings. As we talked about, we're looking to reduce suspension maintenance. The shock replacement time and cost is eliminated with this technology. And then obviously we're always looking to reduce suspension weight. The installed weight when compared to a shock and an air spring is going to be just the shock. You won't have the shock mounts or any of that. So that's our zero maintenance damping air spring technology that Hendrickson's been working on. And that's sort of what the three things that I sort of identified as what is Hendrickson doing to sort of move the ball forward in the marketplace.
Very nice. Nicely done, Bob. Appreciate the information too. And make sure that you actually capture his information there for those of you that want to touch base with Bob too. So Kevin, Scott, I'm going to throw it your direction, buddy.
Okay, awesome. Let me get to my presentation and share my screen here. I'd like to welcome everyone and thank everyone for attending the conference today, and thank you for the invite and allowing us to present I want to start off with talking a little bit about Rayco Graining. Rayco Graining has a very rich history in the suspension industry. We're about to celebrate our 100th birthday. Our founding year was in 1924 in Springfield, Missouri, by the Reynolds Manufacturing Company. And if you look back even further, Graining, as a family-owned forge casting company in Indiana, goes back to the 1800s. So we have a very rich history. We also have a very, very strong history in supporting the fire apparatus marketplace. And Bob touched on some things that were very similar. Our companies are very similar with our FEA, DFMEA, that's finite element analysis, design failure mode, effect analysis, big, sexy engineering terms for CAD design software. And Bob knows this nickname, they're blacksmithers. And they basically build up a suspension and throw it out there and see if it works, and they cross the fingers, right? But Rayco is different. We have been utilizing FEA, finite element analysis, since 1998, DFMEA since 1999, and DVP and R since 2000. So we've been very, very committed to the top-end technology of computer-aided design and engineering. And really, that sets our two companies apart from the rest of the marketplace. When you really look at Rayco and Hendrickson, we're different than most other companies out there in our approach and how we design product and go to market. We take it a little step further in that we have some technology called Topology Optimization, which we utilize through our software package of Altair. And then we also do suspension simulation, kinematic designs, ride and drive handling, etc., through computer-aided engineering as well. So just kind of wanted to throw that out there. If you're looking for technology of companies that are technology based, we're the guys.
Hey Scott. Hey Scott, can you expand your PowerPoint?
It's
Make it larger.
It's the button next to the negative button.
Yep. Thank you.
Can. Yep. Well, why won't it do it? There we go. Okay, perfect. Sorry about that. Okay, so I'm going to talk a little bit about front suspensions for fire apparatus, and what are the differences between the two main types of front suspensions. There basically are three out there. I'm going to address two for right now. So let's take a look at them. So when you look at the options that are available out there, you have an independent front suspension and you have a spring and beam. One of the things that you can see right away is, wow, this looks really, not as big and robust as this does. Keep in mind that with this system, we incorporate a lot of the chassis structure into this, and we also absorb a lot of componentry that's traditionally placed on the chassis into a subassembly for the manufacturer. So let's take a look at what some of these things are. So we have an upper air spring tower. It adds some rigidity to the chassis. And then here we have our relay rod, commonly known as drag link, which attaches to your gearboxes, etc., in between the two hubs. What takes the place of a beam are the upper and lower control arms. So when you think of a beam on an independent front suspension system, it's basically right here in these four parts. You got two on each side. The characteristics are the same, and basically you got wheel hubs, steering knuckles and carriers, etc. But we also have our main and auxiliary gearboxes that are mounted again as a subassembly for the manufacturer. This does a couple of things. It makes the production process much more efficient and quicker. It also allows for a faster design and integration of a new fire truck design. So what's the difference between an independent front suspension and a spring and beam? Well, with a spring and beam, both wheels are connected by a common axle. So I kind of use a pin as an example here. You got the wheels here. And so what happens on this end can typically has a counter effect on the other end. So if this end experiences a bump, then you have a counter effect on the other end of the axle. Whereas in independent front suspension, what happens on one side doesn't affect the other side. And because of that, you also have dynamic camber change during that. So during cornering, your tire tread contact stays in touch with the road much more readily, and you get a tighter biting type action from the tire to keep the vehicle under, in good handling because of that tire tread contact on the road. There's also something called unsprung mass. Going back, let me go back. When you look at unsprung mass, that is the mass that is not sprung. So this whole aspect would be unsprung mass. And in our case, the hubs would be equal, right? Because they're equal on both. They got to carry a specific load. They have a rating involved there. They have brakes, etc. But the difference is between the upper and the lower control arms versus the mass of the beam. So we're much lighter with our mass as far as that part of the suspension that is unsprung. And why is that important? Once you have a mass excited and it is going through the motions, it's much more difficult to dampen it and calm it down. So our goal when we develop our suspensions are to calm the excitation of the wheel end within 2.5 cycles at most. We do not want to go over 2.5 cycles. We want to calm that wheel end down as quickly as possible. And we can do that because of that lightweight unsprung mass being more easily controlled. So if you take a 100-pound ball and you put it into motion, it's much more difficult to control that than if you had a 10-pound ball, for example. You can control that a whole lot easier. So it's kind of the idea that's there. One of the things that it also is important here, when you're specifying suspensions, you have to keep in mind that a suspension is like an electrical fuse. It is, it's that guardian component that isolates events or actions that are seen, unforeseen, etc., and is that safety fuse for the rest of the chassis. So you really need to understand suspensions when you get into speccing them to ensure that you're getting the right product.
Hey, Scott, let me ask you a question on that,
Sure.
that previous slide that you had.
Sure.
Is that independent front suspension versus that that straight actually have? Obviously adds more weight to the vehicle.
Correct.
Yeah, and so you have to account for the additional weight on the front.
We incorporate some of the chassis componentry structure. So it adds a little bit of weight. It might be about 200 pounds or so, but it's not a lot. It looks massive, but you have to keep in mind, we pull a lot of the components that are already being attached to the chassis and incorporating that into a subassembly into one unit. So although it looks intimidating, it's really just a consolidation of a lot of other components that are on that chassis already.
Okay, thank you.
So we talked about unsprung mass. We also have air retention kits for the IFS if you have outriggers. Another interesting thing about about the independent front suspension, or actually any front suspension with air ride, is that you can actually kneel the front, so that if you need to creep under a bridge or into a parking garage or into the firehouse and you need just a couple more inches, you can actually remove the air from the air springs, dump the air springs, and then creep up underneath the garage or the firehouse, etc., to clear the doors. So we're talking about new technology. So that's the exciting thing about independent front suspensions for fire trucks. We entered the market in 2011 into the fire truck industry. And so we really kind of revolutionized what a front suspension should be on a fire apparatus. You know, the solid spring and beam technology has been in place since 1750 on a carriage. And so the independent front suspension is the latest and greatest in technology. Some of the advantages of independent front suspensions, number one, is more uniform tire wear, because remember, you have dynamic cambering with the independent suspension, because when you have a spring and beam, your tires actually go through a roll. They actually make a circle when they try to make curves, etc. So they'll roll a little more on the shoulder or the heel of the tire. Whereas with the independent, you have the dynamic cambering, so that tread stays more engaged and more in contact with the road, so it's much more evenly, much more even tire wear. We use rubber bushings as opposed to hard bush joints. That's going to give you a much more easily way of maintaining the unit. We've also used some very long life bush joints in our suspensions, and they're very impressive in the marketplace. It gives you less road noise. Obviously, the rubber is going to give you a much softer ride, and then with the handling of an IFS, you're going to have much better handling for that tire patch optimized steering geometry. So we can hit 55 degrees with a 385 tire, which gives you wonderful wall-to-wall as far as your turning diameters are concerned. Low camber change. So there again, the tires bite in. Our springs are moved as far outboard as we can possibly get, which gives you great roll stability and correction in the side to side or the rake of the vehicle. The ride quality is superb, because what happens on one side of that suspension is isolated from the other. And, you know, I've heard a lot of people say, well, why do I need to give my fireman a good ride? Well, guess what else you're giving a good ride to? You're giving a good ride to the chassis. And if that suspension is doing what it's supposed to do and be that fuse in the system to isolate that road noise and those road events, then it's giving a good ride to the chassis. That means, you know, that your hinges and your doors and your other your firefighting apparatus components are going to be less damaged. They're going to not take those hits if the suspension's actually doing what it's supposed to do, and we do that. You know, I talked about the improved packaging with a 55-degree cramp angle, which gives you improved maneuverability. Dual ride height control. I kind of talked about that a second ago. So, you know, we were talking earlier about, you know, the right side being a little heavier than the left. With utilizing dual right height control sensors, leveling valves, we can make those corrections with air very readily. Our ride heights are dynamic. So as the load changes, we will keep that ride height constant. So for example, you may have 4 or 5 firefighters in a cab on one trip with all of their equipment, and they're weighed out at about 300 pounds with all of their equipment. Well, maybe there's a trip with 2 firefighters that go out in that cab, and that's 1,000-pound difference. Well, our ride height will stay constant because it adjusts according to the load and what's happening with the road surface. Better isolation from the roads. Air is the best isolation medium to use when it comes to isolating, you know, road events. Air is the best product that you can use. And that's pretty much well it.
Okay, Scott, let me throw a question at you here because I think there's one that's relative to your independent front suspension that Gregory asked. He says, in my area, a lot of departments stay far away from independent front suspensions because they fear the cost of maintaining them versus standard leaf springs, which will be much higher. Any comments?
Okay, so with like the alignment, we have the capability of doing caster, camber, and toe alignment, and it's with eccentric bolts. Our alignment's probably going to take you less than 30 minutes. The wear items, I mean, we use standard industry Bendix brakes, disc brakes. Air springs are readily available in just about any truck supply house, parts store around the nation. We really, you know, what are they basing the maintenance question on? I mean, has there been some direct experience with the IFS maintenance? Because related to what?
Well, from my experience in the departments I've been around, Scott, a lot of it has to do with the twin steering boxes, twin drag links, maintaining those, and then also the maintenance on the individual IFS itself. So upper and lower control arms, things like that.
So our anytime you get up over the 20K rating, you're going to go to multiple gearboxes. So that's going to be a given. Okay. So, and we use a standard TRW TAS 85 gearbox. So it's easily maintained. You know, as far as the upper and lower control arms, I have not actually heard of anyone having maintenance issues on those. We have 2,500 of our IFS units on mission worldwide, United States, Korea, Japan, throughout South America and Brazil, Colombia, etc. But as far as maintenance with the A-arms, no.
Okay.
No.
So Bob, let me fire a question at you that's coming in from the audience.
Okay.
With that on composite springs, are composite spring suspensions available now to fire apparatus OEMs, and at what rating?
Yeah, I knew Mr. Witt would throw that question at me, just knowing him. But they are not today. That's a technology that we are looking to roll out here in the next year to two. Right now, they're being used on a number of different trailer configurations. They're being used on some heavy truck configurations. It's a play in terms of getting the volume there and getting customers comfortable with it, so we can invest in tooling up those different springs. But our plan is to roll that into our SteerTech NXT product.
Okay, well, and you know what? I really appreciate the composite spring side of that, because so much information, so many investigations and recalls have gone out because of corrosion. A lot of times on the frame side, and you're also looking on the suspension side with the springs. And for whatever reason, with all the stuff we're dealing with on the road, it always seems to start around the spring brackets and then on a frame, and then actually rolls into the springs themselves. So I appreciate that. And Scott, I would imagine as far as your rear axles too, you're using the spring side of that for the Raycos as well, and Rayco granting.
Yes, we have the mechanical and the air ride as well. We're known for our ease of alignment options that we have with our suspensions. We actually look at alignment and maintenance early on in our SSD process. That's our Synchronized Solution Development Program.
Okay.
Through GATE. So we make sure that we're going to make these units as easily maintenanceable, or the least amount of maintenance possible, you know, for the end customer.
Okay, here's another question too for
Brian,
you.
Brian,
Yeah,
we're
go
going to
ahead.
run a couple minutes late, so definitely let's keep rapid fire these questions, and let's try and keep
Yep.
There's two great questions I would really like to address.
Yep.
Okay, so I think the one is IFS components are not assumed proprietary, are able to outsource locally and not just from the OEM.
I'm sorry, say that one more time.
So it says from the audience, as to independent front suspension components, I assume they're not proprietary?
The
And they're
brakes,
able to source locally, not just from the OEM.
yeah, the brakes are available locally. The gearbox components are available locally. The proprietary items that you see there would be our ball joints. We do have a couple ball joints on there. We use a kingpin. Unlike our competition that has an IFS, they use a ball joint instead of a kingpin. But we use a ball joint on the connecting rod. But most of all of those components can be locally sourced.
Okay, this is getting, the next one's going to be for both of you. What are y'all doing to combat the issues with air ride, especially with moisture, freezing, body roll, cost of maintenance, and leak down? Bob, I'll let you go first.
Yeah, I mean, obviously, are you talking front or rear, right? Because
Sure.
the way we address it in the rear, because when you go in a turn and you have an air ride suspension, the air suspension can only react as quick as you can funnel air to it, right? So when you have a load change, that air spring has to be able to react. So the way we handle it is through the use of torque rods. And so we typically will put a longitudinal torque rod, which is a fore and aft torque rod, to help that suspension utilize the axle and create like a torsion bar.
Okay.
That's how Hendrickson controls it.
Okay. What about freezing and moisture, especially areas that have condensation when you have condensation in the air?
Yeah, typically we'll use, well, we're both sort of using the same high control valves, which is what you're talking about. So that they'll use the air dryer a lot of times on those to try to blow it out.
Okay. Very good. Scott?
Yes. So yeah, it's basically the same. We do have a proprietary height control valve that we're currently testing that is also extremely heat resistant, since we do have some extreme desert type situations that we're contending with, and also high temp air springs.
Okay. And this one's from Dan. Does an IFS built fire truck come with its own alignment specification as per the build?
The answer would be yes, because each OEM, well, the alignment process is the same. The question would be as to the specs as far as the OEM.
Okay.
Okay. The process.
Go ahead.
Yeah, the process is the same. So somebody asked about special tools required.
Yep.
There are no special tools. The only special tool that we have is a ball joint tool that can be sent overnight, and there's probably a shop near you that already has one.
Okay. So how about the one from Terry? What happens in suspensions when you overspec a suspension in the build stage to add future equipment?
It's going to ride harder. You're not going to have the comfortable ride that you might expect for a while until you load it down, typically. Bob, you concur?
Yeah, I mean, obviously that is different on a spring ride versus an air ride suspension. Air ride typically doesn't care, which is why we're proponents of air rides on the rear, in that they don't care how much load is on them, as long as it's within a certain range, where spring rides are definitely more susceptible to weight and the issues that are there than when typically people overspring the suspension when they're selecting too high of a spring capacity. There's not enough weight or force to move that suspension, and then you're riding on the spring rate of the tire, which essentially equates to a bad ride.
If you're around 2,000 pounds with us, you're not. It's kind of innocuous as long as you're within 2,000 pounds. If you go 4,000 pounds, it's going to be noticeable.
All right, Brian, two more questions.
Okay, so let's go on to what's the expected lifespan of an airbag on the air suspension?
I believe the answer to that's 6 years.
Okay. And then are the ZMDs available in fire applications yet?
They are not. That is a technology that will be rolled in here within the next year.
Okay. Last question.
It'll be, yeah, it'll be available on our FireMax suspension.
So in 2022?
Yes.
Very good. One more. In an emergency situation, if an airbag, air shock fails, can the vehicle still be driven within the limits to the emergency scene, or is the apparatus out of service?
Yes, we have we have bump stops built into all of our air springs so that if you do have a failure, you can complete your mission. It's not going to be fun, okay, to complete the mission, but you're going to be able to complete the mission and then get it addressed after your mission is accomplished.
Okay.
Brian, there's one more in the chat there from Ed.
Okay. So from Ed, on an IFS suspension, how's the clearance for the engine components like, how's the clearance from the engine component to the oil pan?
How is it?
Well, what's the difference there? Is there enough room between the two of them?
Oh yeah, absolutely. There's, and it depends on the OEM. Typically, I think there's probably 3 to 4 inches there. Our cross members are removable so that if you do need to access, the bottom side of the engine or the transmission and access inside the transmission, you can actually drop out those cross members and then splay the suspension and get up inside of the transmission. Very simple.
Okay, there's one really good one here, and then let's wrap it up here, gentlemen. Do you see the use of hydraulic suspension like used in ambulances coming to larger fire apparatus in the future?
There are limitations of silicon gel, which especially in cold environments, we know that when it hits 0, it becomes a brick. And so and we've actually done some studies on that. And so we're not fans of silicone suspensions. It's not a good media to use. And plus, if you lose the medium, you are done. You're not going anywhere. You are out of service.
Okay. Bob?
I do think you will see it. I don't think you're going to see a silicone based. I know if you were to look at a electric fire truck that's being used to run around the fire, the country today, it does have a hydraulic type suspension on it that does allow some of that kneeling capabilities that you talked about, which would be really good. It's just a matter of packaging. I know that we've got a technology that's out already. So I do see it eventually coming into the fire service. It's just at what point.
Okay. Gentlemen, you've been awesome. Greatly appreciate your information and providing that. And Scott, if you would, just kind of in a chat area, if you would put your contact information in there, see if somebody needs to get a hold of you. But you guys have been fabulous. And what a great segue from the tire side to the suspension side.
It was fun. Thank you.
Yeah, it really does. So thank you both very much.
Appreciate you having us.
You're welcome.
Thank you.
Thank you, gentlemen.